This video is the continuous for our module 4. If you still remember, I did tell you that I'm going to finish all the module 4 in all short videos. And last time I did cover module 4.1 and then 4.2, 4.3 and 4.4, and now I'm going to finish our module 5, which is 4.5. We're going to look into instruction format. It will cover the overview, instruction length, allocation bits, and a variable length instruction. So basically it is just a small pieces that we need to cover in 4.5, and this video is short only, but yeah, we can go through it now. Okay, the overview of 4.4, and instructions format define the layout of the bits of n instructions. So later on we're going to look into how instruction layout will be look like in terms of its constituencies fields. Okay, an instruction format must include opcode. This one we already looked into about the format and implicity of explicity and explicity, 0 or more operand. We already looked on also how many operand that available. Normally it is we can also have 0, and the maximum we can also have 3, isn't it? So the format, later on we're going to look into if it is 0, how it's going to look like. If it is 1 operand, how it's going to look like, 2 and 3. So next is the format must implicitly and explicitly indicate the addressing mode for each operand. For most instruction set, more than one instruction format is used. So over here we have 4 basic common instruction formats. As I already mentioned, we're going to have also 0 address instructions. When in under 0 address instructions, there are no operand at all. You can see it is totally only the opcode. What is opcode? I guess it is under 4.2, isn't it? Operation code 4.2. Maybe you can look it back, but you can see if there is no operand at all, it is all under opcode. So this is how the instructions look like if you have 0 address instruction. If you have 1 address instructions, let's say like this, you can have the format instructions like this. If you have 2 address instruction, you can see normally you have 2 in your normal codes, which is, let's say this one is your EAX, your register, and let's say for your second operand or your address 2, it's maybe you can have 100 hexa hexadecimal, or maybe you can just direct put in, maybe this one is call. So everything over here will be putting in here, and it is depend on your opcode. If you have instruction like move, then you're going to move it over here. If add, then you will add these 2 addressings. Depend on what is the codes that stated over here. Maybe it is just a value, or maybe it is an address, which is you use like this. Let's say at the 4000. Sorry, okay. So what is the value in this address? So you need to look into your step. So let's say over here is 4000. Then you look into the address, the value inside that address, and then you will feed in into your register. So this is just an example. And another last common instruction is three address instructions. You can see over here you have a code, and there is three addresses. It is not too new for you because normally you are already play around with your programming the codes. So I think you already look into all of this, especially in your lab too. What happened to my mouse? Okay. In your lab too, you look into several different kind of codes. So I guess it is easy for you to understand. So next we're going to look into instruction length. This decision effect and is affected by memory size, of course, memory organizations, bus structures, processor complexity, and lastly the processor speeds. Trade-off between powerful instruction, repertory, and saving space. Other issues, what might come in is like instruction length equal or multiple to memory transfer length system bus, or it's can called as a system bus. So if you want extra notes, you can refer to this Pearson Education Limited books. So allocations of bits. We have looked at some of factors that go into deciding the length of the instruction format. And equal different issues is how to allocate the bits in that format, and trade-off here are complex. So you can see there is a few 1, 2, 3, 4, 5, 6 all together. In terms of addressing bits, the following interrelated factors go into determining the use of the addressing bits. So there are 6 altogether. First, the number of addressing modes. Second is numbers of operands, register versus memory, number, register set, address range, and lastly the address granularity. So this is the factors that will affect the addressing bits. You can read all the descriptions of all these 6 factors. So it is also related to decision effect. Next is under variable length instructions. Designer may choose. Designer, who is the designer? You are the designer, which is you are the one that need to create their program, or maybe you want to create a software or something else. You need to design. So you must choose instead of provide a variety of instruction format of different lengths. Of course, because you can have many options. These tactics makes it easy to provide a large repertoire of opcodes with different opcode links. Addressing can be more flexible with various combinations of register, memory, references, plus addressing modes. With variable length instructions, these many variations can be provided effectively and compactly. So we can summarize for all in our module 6 is in this chapter discuss on what an instruction set does by examining the type of operands and operation, of course, that may be specified by machine's instructions. Second is describe the various type of addressing mode commands in the instruction set. Present an overview of essential characteristics of machine's instructions and summarize the issues of threats of involved in designing an instruction format. So I guess you can also check and take a look into what the question that can be asked throughout what we have learned and covered in our module 4, and there are several you can see. So maybe you can try to read the question and try to answer all the questions that given. If you can answer it all, means that you have fully understands of what you have learned in your module 4. So thank you for your watching. Please try to look back all the videos that I've provided, and later on we will continue with our module 5, more theory, readings, and etc. So thank you, and please be safe, and salam shawal. Bye bye.